Hi, my dear NEET aspirants, IIT JEE aspirants. Please welcome to SRUSHTI BHANU MOORTHY's House of Conceptual Physics. Now this is video class number 12. I am going to present some concepts from torque and angular momentum. So these topics, these hints and concepts will help to you in getting good score, in securing good marks in NEET entrance examination as well as upcoming April IIT JEE entrance examination. So let us go to concepts now, torque concepts immediately. Now, generally torque is a turning effect of force. My dear students, listen carefully. Torque is a turning effect of force about a fixed point. So these are the fundamentals I have given now. First one, first, second, third, fourth, fundamental equations these are on torque. Torque actually is a turning effect of a force. Any object, unless we apply some external force, the body does not rotate. Suppose this example, a rod. It is a rod, for example, let us treat it as a rod. Now this is a fixed point. About fixed point, the rod is rotating now like this. So turning now. Here, if we apply some force here, we are exerting some force in this point of application of force. Then this is a position vector from the fixed point. So we have force applied at this point and distance, maintaining some distance from the fixed point. So because of these two factors, the body is turning about this point. The door, window can be rotated about the hinge. Hinge can be acted as the axis of rotation. Fixed point. So about the fixed point, the turning effect of force, if force is applied, okay, at a particular distance from the fixed point, then the body turns. This turning effect of force is called as torque. So torque is a vector quantity. It acts perpendicular to the plane of rotation. So this is a plane of rotation, torque acts perpendicular. So depending upon screw rule, right-handed screw rule, if it is rotated clockwise, anti-clockwise direction, it goes up. It rotates clockwise rotation oriented. So orientation, then screw comes down. According to Car's screw rule, we can represent the direction of torque as well as angular momentum. So these are axial vectors. Okay, so they act along the axis of rotation and they are perpendicular to the plane of rotation. So if the rod rotates like this, for this plane of rotation, torque will be a perpendicular direction along the axis of rotation. In anti-clockwise orientation, torque will be acted upwards. In clockwise orientation, torque will be acted downwards. So this is a representation now. This is a point of application of force here, and position vector is represented here. So then the body is rotating in anti-clockwise direction. So R cross F, R to F. Then torque will be in this direction, which is perpendicular to the plane containing F bar and R bar. So this is a basic definition of torque. Okay. Now torque formulas are R cross F. It's a cross product of position vector as well as force vector, and F R F sin theta. Then equilibrium condition. Equilibrium condition means what? R1 F1 equals to R2 F2. So if clockwise orientation, clockwise torque, anti-clockwise torque, both are equal in magnitude, the body does not rotate. So this is a condition for equilibrium. About the fixed point, if torque and clockwise orientation torque and anti-clockwise orientation torque both are equal, the body does not turn. So the turning effect becomes 0. The torque acting on the particle becomes 0. So condition for equilibrium is R1 F1 equals to R2 F2. Okay. So equilibrium condition, so that the body does not rotate or spin. Now torque formulas 2 equals to I alpha. I for moment of inertia, alpha is angular acceleration. So alpha means omega 2 minus omega 1 by t. So just like in linear quantities, in linear motion, acceleration is v minus u by t, like that, omega 2 minus omega 1 by t, angular quantities there. And 2 equals to I into alpha. Alpha another name formula, v omega 2 square minus omega 1 square by 2 theta. So this can be written as v square minus u square by 2s, like that. Okay. So angular quantities, angular equations are similar to, analog to linear equations. You know that well. Okay. Now I don't want to go in depth on these fundamental formulas. Okay. Now torque is, another definition is rate of change of angular momentum. Angular momentum is L here. Suppose if torque is on the body is 0, if external torque on the body is 0, its angular momentum remains constant. Its angular momentum remains constant if there is no torque on the body. Okay, these are the fundamentals of torque. Now let us go to applications in torque. First application I am going to tell now here. The two loads are kept here on this horizontal rod. Okay, this is a fulcrum. This is called as a fulcrum, a tilting point. About this tilting point, the rod is rotating like this. About this tilting point, or screw point, the rod is tilting now. So that's why we can call it as a tilting point. Okay. So about this tilting point, first load is 6 kg mass is kept here at a distance 20 centimeter, and second load M is kept at a distance 30 centimeter on the horizontal rod. Okay, so what is the equilibrium condition? F1R1 equals to F2R2, so that the rod remains in equilibrium position, horizontal position. It remains in horizontal position under these two loads. Okay, so it can be treated as F1, it can be treated as F2. F1 equals to 6 into F1 here. F1 is nothing but mg, no? M1 into G, that equal to 6G. This equals to F2 equals to capital M into G. Okay, these two forces are acting downward direction, and this is R1 and this is R2. Okay, my dear students. So then you can understand here equilibrium condition. So for what value of M the rod remains in horizontal? That is the question. Diagram will be given in the entrance examination, and the question is for what value of M kg the rod remains in equilibrium. Then we can substitute these values in this formula. F1 into R1 equals to F2 into R2. So this is a condition for equilibrium, right? Okay, let us go to next application of torque now with the help of this one. So here triangle, equilateral triangle is represented here. So three forces are acting here in their respective directions. Along AB, F1 force is acting. Along BC, F2 force is acting. Along AC, F3 force is acting. Okay, now the question is, if torque about this point O is 0, if there is no torque, if this system is not rotating, no torque means no rotation. So if the system is not rotating, not spinning, then what is the relation among these three forces? That is the question. So relation is what? These two are, this is anti-clockwise orientation torque. It is also anti-clockwise torque, but it is clockwise torque. Okay, my dear students, remember this point. So, anti-clockwise torques 2 here, and clockwise torque is this one. Okay, so these two anti-clockwise, this is clockwise. Therefore, clockwise orientation torque is equal to sum of two anti-clockwise torques. Okay, tau 3 equals to tau 1 plus tau 2 we can represent. Here, perpendicular distance means this is perpendicular R, and this is perpendicular R, and this is perpendicular R. So perpendicular distances are equal, you know. Okay, so F3 into R equal to F1 into R plus F2 into R. So R gets cancelled, you will get this formula. So this is the very important concept from torque topic. Okay, so if the system is not rotating means what is the information I am going to give? Anti-clockwise torques is equal to clockwise torques. You should remember this point. Here also, this is rotating in anti-clockwise rotation. It tries to rotate in this direction, and this block tries to rotate in this direction. So this is anti-clockwise torque, and this is clockwise torque. If these two torques are equal, in magnitude, opposite in direction, the block does not rotate. This is the most important concept here. So these two applications are representing the same condition for equilibrium. Okay. Now let us go to another concept of torque quickly. Now this is a metal rod. Okay. So whatever the length it may be, length is given, mass is given. Mass will be concentrated at the center. Remember this point, okay? Mass will be concentrated at the center because it is a uniform rod. Okay, so this rod is kept horizontally. It is released from horizontal position about the point A. So this rod is about the point A means it is fixed to this point here A, and the rod is kept horizontally. If the rod is released, like this. Initially it was horizontal, now it is released. Initially it is horizontal, now it is released. Then what happens? See, it turns about this point A. When the rod in equilibrium position is horizontal position about point A, when it is released, then its angular acceleration is how much? My dear students, NEET students, very, very important concept it is for NEET entrance as well as IIT JEE entrance point of view. Now, tau equals to I alpha, I show what? Moment of inertia. Now, let us discuss in detail about moment of inertia of different objects. Moment of inertia is an inherent property of a body. For ring, discus, rod, cylinder, solid sphere, hollow sphere, for different objects, moment of inertia is different. And it depends upon the position of the axis also. So, if the axis is passing through the end of this metal rod, then what is its moment of inertia? ml square by 3. So, you studied in previous classes already about moment of inertia and their formulas for different axes of position, okay, different positions of the axis. So, here this axis is passing through the end of the rod. So, axis is passing through the end of this rod. Mass is given, length given. Axis is passing through the rod. Now, about this axis, it is rotating like this, okay, it is moving about this axis. Okay, so then what is the moment of inertia? ml square by 3 into alpha. Alpha means angular acceleration. Okay, so but torque definition is Fr, you know, Fr. Okay, so F into R equals to ml square by 3 into alpha. You can calculate alpha from this. F means total mass is concentrated. Force is applied here. This is the force application. F equals to mg here. So force is applied at the center. Okay, force is not applied, but due to its center of mass, total mass is concentrated at the center. So that's why due to its own weight, it comes down. So this is a point of application of force, F equal to mg. Mg I am putting here into a perpendicular distance from the position, fixed point. From the fixed point, perpendicular position from the force is L by 2. So, mg into L by 2, F into R is equals to its moment of inertia about this axis passing through the end of the rod, that is ml square by 3 into alpha. From this relation, you can get angular acceleration. My dear NEET students, if you are interested to know about numericals based on these concepts, all these concepts I am projecting to you, if you are interested to listen different applications, methodology in this concept, you please contact to these numbers and book your seats. Now I am going to start crash course. It will be started from 2nd April. The crash course will be started from 2nd April for NEET aspirants. So book your seat and take admission quickly, and you can hear more and more numericals from different concepts from first year as well as second year. So I will finish first year and second year syllabus in 35 days from April 2nd to May 6th onwards, because you are going to write examination on May 7th, you know. So in 35 days I am going to finish all those chapters, weightage chapters. Okay, it will be helpful to you. If you are interested to come to this institution, please like these videos, share these videos and subscribe these videos. Don't forget to press the bell button. Okay, so do viral these videos to all your friend circle without forgetting. Okay, now let us move to next concept here clearly. Now this is a ball, a metal ball is placed on one of the stairs of a staircase. Each of width, height, each stair height is B. Okay, each step height is B. Okay, now this metal ball of mass m here, its weight is downwards. Of mass m is held on the step, one of the steps. Okay, its height is B. Now we want to roll. We want to tilt the metal ball onto the upper step by applying this external force F, horizontal force. The question is, with what force, what should be the horizontal force required to roll the ball onto the upper step? To roll the ball onto the upper step about this fixed point. The fixed point here is a tilting point that is represented here P. P is the tilting point because the ball is rolling about this tilting point, like this tilting point. Okay. Suppose if you take rectangular objects now, it is now tilting. It is now tilting on the surface now. Okay. This is called as tilting point, like this, like this. Okay. So about this tilting point P, the ball has to be rotated, rolled onto the upper step. So what should be the minimum horizontal force required? Okay, so this is the question. It is the concept of torque. Now two forces are there, my dear students. Just to tilt means equilibrium condition. So F1 into R1 here from the fixed point, this is R1. Force into perpendicular distance R1. And F2 is weight of the ball, downward direction, mass is given there. So and R2 from the fixed point, this is R2. So force into perpendicular distance from the fixed point, tilting point, and force F2 into perpendicular distance from the tilting point. Always we should measure the distances from the tilting point, recognize this point. So F1 into R1 is equals to F2 into R2. This is the concept. Now based on this torque concept we can do the calculation. Okay, F we want actually. See, F1 R1 equal to F2 R2. F2 means mg here, and R1 R2 values, because the radius of the ball is given, radius capital R given, height of the step is given, radius and height both are given to you in entrance examination. Then you can substitute R1 value. How R1 value means total is capital R minus B. This is B. So then it becomes what? R minus B. Right? So from here to here, R1 value how much here? R minus B you can enter. Next, R2 value. How to find out R2 value? Pythagoras theorem, my dear students. Pythagoras theorem means R2 equal to square root of this square minus this square. Square root of R square minus this square. So if you substitute the values here, you will get force required to tilt the ball onto the upper step. Very, very important concept, my dear students. Okay, this is the information I am going to give here. Let us move quickly to another concept of torque. So valuable information I am giving to you for the sake of students to get maximum score in securing good marks in entrance examination. So this is the information. Now some more points according to screw rule we can represent the torque direction, angular momentum direction also. These are axial vectors, they act along the axis of rotation. When the body orients in anti-clockwise direction, torque upwards, and clockwise direction, torque downwards. Okay, according to screw rule we can represent the direction. These are called as axial vectors. Now some more important relations I am going to give to you. In the next class, I am going to project angular momentum concepts and some other concepts from rotatory motion. My dear students, this is a rotational dynamics I am giving to you. This is a tough topic actually. It's a very important topic. Definitely 1 or 2 questions will come in entrance examination, NEET entrance. From first year, from each and every chapter, weightage chapters, 2 questions may come out of 45 questions. So 2 questions from this rotational dynamics, you know. So very important topic it is. 2 questions will come. So into 4 marks. If you do correct answer, 4 marks. So 2 questions means 8 marks. Okay. So very important chapter it is. Thermodynamics, rotatory motion. Okay. Some topics are there. Thermodynamics, rotatory motion, oscillations, waves and oscillations. So 2 questions may come from this first year concept. So out of 45 questions, nearly 22 questions from first year and 23 questions from second year, near about in the ratio they can ask the questions. Okay, my dear students, in the next class I am going to project angular momentum concept and some torque concepts also, and moment of inertia concepts from this rotational dynamics. My dear students, please like, share and subscribe these videos to all your friend circle. Please don't forget to press the bell button. So I established this institution in my own house, HARIHARAPURAM colony, nearby Dilshuknagar Public School, VANASTHALIPURAM. So in my own house I established this institution. I have 28 years of teaching experience in Hyderabad. So so many students got good marks in entrance examinations, both the NEET and as well as IIT, JEE entrance exams. So CBSE students also are here in my classes, and I am giving the coaching to USA students also. So my dear students, if you are interested, you please contact these numbers and take admissions quickly for the crash course NEET 2023. Okay. Till then, bye. So in the next class, we are going to project some more concepts in a video class number 13. Till then, bye. Good.